Hello, everyone. We're starting Chapter 3 with the definition of the derivative. The achieved problems aren't fantastic in this section, but we'll make the best out of them and look at what they want you to do here. For their first problem that they gave me, you'll see here it says, let f of x equal the quadratic 3x squared minus 4x minus 7. And then it says the secant line. Remember, a secant line is a line that connects 2 points on a curve. The secant line 2 and f of 2 and 2 plus h and f of 2 plus h has a slope of 3h plus 8. And then it says use this formula to compute the slope of the given lines. Now, what I went ahead and did, I could have used that formula that they found for me up there, but instead, what I did, I know if I wanted to find the average rate of change between 2 points, in part A, it says to find the slope of the secant line between x equals 2 and x equals 3. Well, I just said that the slope is the average rate of change from 2 to 3. So it's the change in the y over the change in the x. Well, that's f of 3 minus f of 2 over 3 minus 2. F of 3 is when you just plug 3 into your function up here. So you'll see that's where I did this. 3 times 3 squared minus 4 times 3 minus 7. Minus f of 2, which is, of course, 3 times 2 squared minus 4 times 2 minus 7. When I simplified out my first group, I had an 8. When I simplified out my second group, I had a negative 3. Now, clearly, the change in the x values is just 1 unit because it's the distance from 2 to 3. So 3 minus 2 is 1. Our denominator is 1. When you subtract your numerators here, 8 minus a negative 3 gives you 8 plus 3 for 11 over 1, our average rate of change of 11. So you'll see that I put the answer of 11 in for that first slope, and it liked it. Now, for part B, it's saying that we're supposed to find the slope of the line at x equal 2 by taking a limit. Okay, so here's what I did for that. In order to work the second part, it needs a derivative. So I went ahead and took the derivative with respect to x, and I used the formula, the limit as h approaches 0 of f of x plus h minus f of x over h. F of x plus h, that's just your function up here with an x plus h everywhere you see an x. So it's 3 times x plus h squared minus 4 times x plus h minus 7. Minus f of x, of course, that's minus your original function. All divided by the distance in your 2x values. We want h units between them so that distance can go to 0 as we take our limit. But remember, we can't take that limit as h approaches 0 until we simplify the numerator and are able to cancel the h out of the denominator. So in simplifying the numerator, I knew x plus h quantities squared would give me x squared plus 2xh plus h squared. Please remember, a binomial squared is always a trinomial. In this case, it's going to be x to the second plus 2xh plus h to the second. If you distribute a 3 throughout that, you'll get 3x squared plus 6xh plus 3h squared. Please don't make algebra errors here and say that this is 3x squared plus 3h squared. That would be a hideous mistake. Now, you'll see I distributed the minus 4 throughout this second group, minus 4x minus 4h minus 7. I'm still subtracting the entire f of x. Now, what I need you to remember here is every single solitary time you have one of these difference quotient problems, the terms of f of x plus h and f of x always cancel. They will never combine. And then the terms that are remaining, you're guaranteed they're going to have a factor of h left, and that's going to allow us to eliminate with the h in the denominator. Okay, so I know the 3x squared minus 3x squared cancels, just like I said they would. Here's my first term that doesn't cancel. It'd be 6xh. I went ahead and I knew every term that wouldn't cancel would have a factor of h. So I went ahead and factored that h out, and I said, well, then I have a 6x left for that first term. Next term, 3h squared doesn't cancel. Factor an h out of that, You're left with plus 3h here. This minus 4x minus a negative 4x cancels. Minus 4h has nothing to cancel. So you'd say, yeah, but John, you're supposed to factor an h out of that. Absolutely. You factor the h out and you have minus 4 left over here. Then you can see the minus 7s do cancel. So now I have h times this expression all over h. I can eliminate h in this step. And I can say that my derivative with respect to x is equal to the limit as h approaches 0 of just this function, 6x plus 3h minus 4. Well, the derivative, which is going to give us the formula for the instantaneous rate of change, only occurs when I allow h to equal 0. If h is 0, then you're going to have 6x minus 4. This tells us that this expression is going to be able to find the instantaneous rate of change of the function f of x with respect to x at any value of x. Now, it wanted to know the slope at x equals 2. So all I have to do is plug a 2 into that formula. 6 times 2 minus 4. I get my 12 minus 4 for 8. And you can see 8 was the solution in this case. That eliminates the need for further discussion for that problem. The next one here, it's pretty quick. It's asking me to compute the derivative for a different quadratic. It's similar but different quadratic. This time f of x is equal to 3x squared plus 5x. And I need to evaluate the derivative at 1. Now, the way I would rather go ahead and do that is to find the derivative using one of our derivative definitions. Again, I'm using f prime of x formula, where the limit as h approaches 0 of f of x plus h minus f of x over h. You could have used any of our derivative formulas here. It doesn't matter which one, they all will give you the same answer. When I say any of the derivative formulas, I mean you could have used f prime of a is equal to the limit as h approaches 0 of f of a plus h minus f of a over h. In fact, that's the exact same formula as the one I'm using, except you would have your answer in terms of a, where a is the point of interest. You could also use f prime of a is equal to the limit as x approaches a of f of x minus f of a over x minus a. All three of these limit definitions of the derivative do the exact same thing. This one just leaves my answer in terms of x, so I chose it in this case. So I said, okay, f prime of x is equal to this limit definition of the derivative. Well, what is f of x plus h? It's your function with an x plus h in the place of x. So you see I have 3 times x plus h squared plus 5 times x plus h minus f of x, which is just minus your function, all over h. Now, again, please remember, x plus h quantity squared is equal to x squared plus 2xh plus h squared. You distribute a 3 through there, and you'll get 3x squared plus 6xh plus 3h squared. Then I'm going to have plus 5x plus 5h minus f of x. Every single solitary time, the terms of f of x cancel with the terms of f of x plus h, and every term that's left will have a factor of h. So I said 3x squareds cancel, 5x cancel. The other 3 terms, this term, this term, and this term, had to have a factor of h. So you'll be wise to go ahead and factor that h out and say, well, you're going to be left over with 6x plus 3h to the first plus 5. That's where all 3 of those terms come from. At this point, I see the numerator is factored. I have that factor of h in the denominator that cannot remain. I can eliminate h in this step. And I have left over the derivative with respect to x is equal to the limit as h approaches 0, and I almost forgot to put that in this step, the limit as h approaches 0 of the expression remaining, 6x plus 3h plus 5. If you allow h to go to 0, notice from this step to this step, I'm dropping the limit because I'm literally plugging a 0 in for h. That gives me 6x plus 0 plus 5, or just 6x plus 5. So now that gives me a formula for any value of x. Our problem wanted to know the derivative at 1, so I just plug a 1 into that, and I'll get 6 times 1 plus 5. We get our 11. I wish they had some way of having you show every one of the beautiful steps in that algebraic solution, but they don't. The next one here, we're looking at the derivative at 2, and I'll be honest, I'm not crazy about the notation required to get to their first answer in this problem. So number 3 here, f of x, again, they give us a quadratic. This time they're asking us specifically to evaluate the expression f of x minus f of 2 over x minus 2. And I need you to think about, well, what is that expression giving you? F of x minus f of 2 over x minus 2, that's giving us the average rate of change from 2 to any value of x. It's the change in y over the change in x as x goes from 2 to x. I can say, well, this function is giving me the average rate of change from 2 to some value of x. Now, if I wanted to go ahead and evaluate this, I'd just plug it in. F of x, that's your function here. Minus f of 2. Well, f of 2 is your function evaluated at 2. Your denominator, x minus 2. Now, I need to simplify that numerator. There's nothing here to simplify yet in the quadratic. But in this, f of 2, I know it's going to be 1 plus 4 minus 6 times 4, so that's 5 minus 24 for a negative 19. Well, now when I take that quadratic and I subtract a negative 19, I wanted to go ahead and put it in descending order. I would have a negative 6x squared plus 2x, and then 1 plus 19 is going to give me plus 20 over there. It's an ugly 0 on the 20. Now, when I'm looking at that numerator and I'm thinking, well, how could this simplify? It could simplify if I could possibly cancel a factor of x minus 2 in the numerator. I don't easily see that the numerator has a factor of x minus 2 right now. So what I chose to do in this step is I've factored out the greatest common factor in all 3 terms of a negative 2. Whenever the leading term is negative, you should factor out a negative, and of course they all have a factor of 2 in common as well. So I factor out a negative 2, leaves me with a positive 3x squared minus x minus 10 remaining. At that point, it's pretty easy to factor the trinomial, especially if you keep in mind, hey, I bet it has a factor of x minus 2, so this problem can reduce. And if you did that, oh, you bet that would be wise. You say negative 2 times x minus 2 times what other factor? Well, x times 3x is 3x squared. Negative 2 times positive 5 is negative 10. And then please notice that'd be 3x squared. You would get plus 5x minus 6x for a total of minus 1x. And then, of course, your minus 10. That is the correct factorization. The x minus 2's cancel out, and we're left with negative 2 times 3x plus 5. That's what I put for my first answer here. Now, the second answer, it's wanting us to compute the derivative and evaluate it at 2. So the derivative is requiring us to plug a 2 into this function. So I could say, well, this is the average rate of change from 2 to any value of x. So if I wanted to find out what happens at 2, I just need to take the limit as x approaches 2 of this limit definition of the derivative. And keep in mind, that has to make sense to you because you're saying, okay, it's the limit as x approaches 2 of f of x minus f of 2 over 2 minus 2. This formula was the average rate of change from 2 to any other value. Well, that other value of x is going to get infinitesimally close to 2. In other words, it's going to tell me the instantaneous rate of change at 2 if I just plug a 2 in for x now. So I can say, well, all right, if I plug a 2 into the formula that I had above here, I have negative 2 times 3 times 2 plus 5. That gives me 6 plus 5 is 11. Negative 2 times 11 should be negative 22 for my instantaneous rate of change. And you can see that that's precisely what it was in this case. Now, when I look at the next problem, it's using the limit definition of the derivative. F prime of a is equal to the limit as h approaches 0 of f of a plus h minus f of a over h. Okay. Well, it actually says use that, or the limit as x approaches a of f of x minus f of a over x minus a. Since it's a polynomial, I think it's better to choose the first one. The second one is fine, but the first one usually works a little bit easier with polynomial functions. You'll see that that is the one that I chose here. And when I go in and I'm evaluating it, I'll go ahead and maximize this screen. When I'm evaluating it, I had f of x is equal to 16x cubed. So f prime of a, I used their first limit definition of the derivative. That's going to be the limit as h approaches 0, f of a plus h. It's the same thing as f of x, except everywhere there's an x, you're going to put an a plus h. So I have 16 times the group a plus h cubed. Then minus f of a, well, that's just minus 16a cubed. Now over here, I showed Pascal's triangle as to how to expand out a plus h to the third power. This was also explained in your notes, so please make sure you see a plus h to the third by the fourth row of Pascal's triangle. We can see that the coefficient should be 1, 3, 3, 1. The 1 is always the coefficient of the full power of the first term, so 1a to the third. And then each other coefficient is going to be in the coefficient of terms where the power descends on the first one and ascends on the second term. So I have 3a to the second h. Please notice how the exponents will always add to be 3, plus 3a to the first h squared, and then plus 1 h cubed. So I know that that is a plus h to the third power. Now, if you would prefer to just multiply a plus h by itself 3 times to get to this expression, you can do that. Probably more time consuming. Now, I have to multiply a 16 times all 4 of those terms. That's where this came from. 16a cubed plus 48a squared h plus 48ah squared plus 16h cubed. Minus your 16a cubed. As in every single solitary time, the terms of f of a plus h and f of a always cancel. They will never combine. So I can say, yeah, the 16a cubes do cancel. Every other term must have a factor of h. So I factored an h out, and I'd be left with 48a squared plus 48ah to the first plus 16h to the second. Now, could have I factored out more than just the h? I could have, but it's probably better not to. The h is the only thing that needs to be eliminated with the denominator. So in this step, I eliminate h and say this derivative is going to equal the limit as h approaches 0 of the expression I have right here, 48a squared plus 48ah plus 16h squared. Well, now, of course, if you let h go to 0, the second and third term go to 0. So your final answer is just going to be 48a to the second. Now, we found the derivative evaluated at a to be 48a to the second. Achieve wanted the derivative evaluated at 2. So I simply plug a 2 in for a, and I would get 48 times 2 squared, which is 48 times 4. And you can see I had my answer of 192 there. Now, whenever you go to this, you can see, yep, that's what he put, the answer 192. When I look at number 5 here, number 5, I have, or I'm supposed to use the limit definition to calculate the derivative at x equals a of the linear function f of x is equal to 2. This one's kind of insultingly easy because with it, whoops, let me make sure I don't mess up my screen here. There we go. I was trying to drag and drop the wrong picture. With it, if you just say, well, the derivative of any constant function, remember, the derivative is the instantaneous rate of change or the slope of that function. And you can say, well, if it's a constant function, by definition, it has a 0 slope. It's never going to rise for any amount of x value change. It has a slope of 0. Well, I just showed that out here. I'd say, well, it's f of a plus h minus f of a over h. There's nowhere to plug an a plus h or an a in. So your numerator, when you try to plug that in, it's just 2 minus 2. which is always 0, and you can see, well, your answer is 0. That is a terrible problem. I don't like that one. Too easy. Up next, it's asking us to evaluate the derivative. I don't like this problem. You're like, geez, John, why? Well, the reason why is because you already know the answer before you work it. It's a linear function. The instantaneous rate of change, or the slope of any linear function, is always its constant slope. Linear functions are the only functions that have a constant slope. This function has a constant slope of 13 no matter what value the z would be in this case. But if I try to show my work for that, now again, I already know the answer is 13, but if you wanted to show it algebraically, how would you do it? They chose to put this with the variable z, so k of z is 13z plus 13. So if I wanted to find the derivative evaluated at the value of a, where a is the value of z of interest, I can say, well, then this is the limit as h approaches 0 of k of a plus h minus k of a over h. What is k of a plus h? It's the same thing as k, but in the place of z, you put an a plus h. So I have 13 times a plus h plus 13 minus the group k evaluated at a is just going to be 13a plus 13. Now I distribute the 13 through the group a plus h, and I have 13a plus 13h plus 13 minus my k of a all over h, and this is still inside of a limit as h approaches 0. As in every single time, the terms of k of a plus h and k of a have to cancel. Well, they do. 13a minus 13a goes away. 13 minus 13, gone. You're left with 13h over 13. And at this point, you know you can eliminate h. And you can say, well, then the limit as h approaches 0 of 13 is just 13. The h canceled out. There's no 0 to plug in. So our final answer there, just 0. Not a very interesting problem. Now, some of the other problems in this section do get a little longer, so I am going to, for the first time, break at this point in the video, and I'll do problems 7 through 11 in a second video for this section 3.1.